Hi everyone, welcome back to my endless list of AP and GP videos. If you appreciate what I'm doing, want to support me, please just press like, that'd be great. So let's have a look at what we're doing. Now, if it didn't tell you it's a geometric progression and it just said calculate the sum of the first 20 terms of those numbers, it's up to your understanding of what's going on here and which formula I'm going to use. Let's have a look at what's happening. So if I looked at it and I thought it was an arithmetic progression, it went up by 5 and it didn't go up by 5. So the next thing you're expecting is it's going to be a GP. What do you do for a GP? Let's have a look at it. We need this big thing called R. And I'm going to talk about again, it's the second term divided by the first term. So the second term, so there's term 1, term 2, term 3. So that's term 2 is its position. And we've got 15 over 10 and you've got 1.5. So most people are okay with that. By the way, if you looked at 22.5 over 15, you'll get the same ratio of 1.5, but the numbers are a bit harder and it mucks people up. So let's look at what we're going to do. We want the sum of n terms, and I'm going to go A, and I'm going to go this way, r to the n minus 1 over r minus 1. So there's our formula, and I could do like in previous videos, instead of proving it to you, I could show it's true. It gets a bit awkward, the numbers get a bit revolting. Though I do have the answers already on my ClassPad calculator, so I can check if I've made mistakes in my calculation. So let's have a look at the sum of the first 20. It gets pretty revolting, and really this can't be of this level in a non-calculator section. So here in Western Australia, the interesting part is then you can use your ClassPad. But it'd be interesting, some people still go back to using the formula and then using basically the scientific calculator of it. So I was debating whether I'd even put this up, but we still need this because of what's coming after it. Let's have a look. So the first term is 10, our common ratio is 1.5, and the n, the position, what position do we want to get up to? We want to get up to 20 terms, and to the 20 minus 1 over the ratio again of 1.5 take 1. And you go, oh my goodness, that's pretty revolting. So if you pick up your scientific calculator and put that in, you can see why it can't be in a non-calculator section. Well, I suppose they could if they just said don't simplify your answer. And you put that in for the sum of the first 20 and you come up with 66,000, bit crazy, I did the crazy on purpose, 0.1346. Old school, I would have written 4 decimal places behind it. And of course you could round it off to maybe, they might say to the nearest whole number. Next twist they can often do is saying, how many terms would it take to get past 60,000? So we'll look at that possibly in another video if I keep making them. Now, what I've done another one for is what's going on with the R in this case. So second term divided by the first term. I could go third term divided by the second term, but it doesn't look as nice. So second term, which is 30, divided by the first term with 40, so we've got 3/4. Now, over here I left it as 1.5. And this one I've written as 3/4. It's up to you which one you prefer. So if I wanted to, I could go 0.75. Go back to our formula, the sum of the terms. Now, you can, old school, I keep talking about old school because I'm old. We would write, if that was bigger than 1, we'd put the R first. Because part of it made the calculations easier, but it actually makes no difference. You can write it either way. So on this one here, because it's smaller than 1, because R is less than 1, traditionally I'd write the formula that way around, 1 minus R to the n on 1 minus R. It makes no difference. So you can write it either way. But interesting if I check on the formula sheet that I've got here. So, interesting that it's written that way on our West Australian formula sheet. And I hadn't checked to see which way it was written, but it doesn't matter which way you write it. So they don't even mention the 2 ways here in Western Australia, they just mention this way. So first term's 40, brackets, 1 minus R. You can probably see why it's easier in some ways to write that at 0.75, even though I avoid decimals wherever I can. How many terms are we counting? We want the first 10 terms, so we want the sum of the first 10 terms. So that's going to be to the 10, and you can see why again, it can't be in a non-calculated section because the numbers are just crazy. So again, I'll put that into my ClassPad calculator, and I've got the answer as 150.0 9898. And again, old school, I'd put 4 decimal places. Probably in reality, most of the time in a question like this, if you round it off to 1 decimal place, you're going to end up with it being 151. So interesting, I'd look at it and I'd go 2 decimal places if I had it there. So is that a bigger number, a smaller number? The 8 becomes a 9 and you end up with 150.99 to 2 decimal places. It was interesting, I was sitting there on my class pad and making up numbers and what will I do and what examples will I do, what numbers will I get to, and I clicked on this one being 150.9898 and I thought that's a bit of an interesting one to look at. So that's how we can sum a whole lot of terms. And basically, in most cases, I think people would go to the formula, but I'm not going to show you right here now. You can watch videos on it. There's lots of videos showing you how to do it on ClassPad. So if I have a look at these 2 questions and go back and see what's happened and why I picked them, on this case, I was getting bigger and bigger. I could have gone double or triple and I decided to go, let's make it a little bit tricky, being a 1.5. And if you're multiplying by more than 1, of course, it's going to get bigger and bigger and bigger. And by the way, the next topic coming up, we're going to talk about limits. That will have no limit to it. It'll just keep getting bigger and bigger. And as you look at the first 20 terms, it just goes berserk, absolutely berserk. In this case, what I looked at is what if the numbers are becoming smaller? And you can see the answer this time didn't go anywhere near as crazy. It'd be interesting if I actually checked what that was for 20 terms. So I'm going to look at that. So I'm going to look at the sum of the first 20. The interesting part when you get the sum of the first 20, it's not going to become much bigger because as this gets smaller, we're adding less and less and less each time. So the number I've got written down over here for 20 is 159.4926, 4 decimal places, and then you could round that off. Probably a lot of people would round that off to 159.5 or 0.49, about 5 for 1 decimal place. So you can see that as the numbers are getting bigger, your sum just gets bigger and bigger and bigger, but as the numbers are getting smaller, the amount you're adding each time is getting less and less, so it's not increasing all that much. Now, you look at both of these topics and you can go to, what if I had a negative involved? So what if I was multiplying by negative 1.5? Or what if I was multiplying by negative 0.75? So really, without making another video of it, that one would become a negative, so I'd go positive, negative, positive, and the next one would be negative. So positive, negative, positive, negative. And it changes your calculations because some will be adding and some will be subtracting until you get to a total. It's almost like you're going, especially when you're getting smaller, it's like you add a big bit, subtract not quite as much, add a bit more, not as much again, subtract a bit, and you keep going. Oh my goodness, it goes on and on. Thanks for watching. If you enjoyed it, please press like and let your friends know, and thanks for watching.